record this. Okay, so in the last class, we started talking about the physical design of IoT. So in there, we started talking about, like the two categories of physical design. That means the things and uh, the protocols. So under things, we talked about the devices that are used, the sensors, uh, and so on. So the hardware devices that are used for IoT communications, we call as things. So these hardware devices are not just devices, they are known as smart objects. So these devices have the ability to collect information and also communicate that to a server which has connection to the internet. So the total entity that has the ability to collect data and communicate data to a server, we call as a thing. So thing is a smart object. So we have talked about things as the first category, and at the second category we started talking about the protocols in IoT networks, and the protocols under physical and data link layer we started talking about. So basically IoT protocols enable the communication from the devices to the servers and from the servers to devices to happen in a standard such that there's no like different communications happening or different way of communication happening with devices. So we only have one standard, so we need to follow that standard to communicate with the server. So once we follow the certain standard, we can reliably communicate our data to the server. So therefore, we need to use a set of predefined standards for our IoT network, so that every person who's implementing an IoT network will follow the same procedure under a certain protocol, so that so this IoT network will function anywhere under the standards, so it can be plugged in and used in any other network as well. So because of that flexibility, we need to follow the protocols to implement our IoT networks. Okay, so I will discuss about the problems you have regarding the timetable at the end of today's lecture. So we will get to that. So currently, I will continue the lecture from what we stopped last time, so that we will, have a continuation. So if some students were absent or they were unable to log into this lecture last time, so I think some resources are already available in the LMS. Apart from that, if you need more like clarification about the content covered, you can actually email me, or you can let me know by call. I will answer the questions you have. So we have talked about the physical layer, data link layer protocols such as Bluetooth, Zigbee, LoRa, Wi-Fi in the last lecture. So we talked about the specifications and like in what standards they are working on and so on. And then we talked about the network layer protocols that are used widely, that are IPv4, IPv6 addressing, and internet uh, protocols based on that define the packet format and so on. And then we have talked about the 6LoWPAN protocol, which is used mostly in constrained environments. Next, we talked about the TCP or Transmission Control Protocol and the UDP, the User Datagram Protocol, which are used for in the transport layer to ensure that the packets are reaching through a certain route to its destination. So we have talked about those protocols, and currently we are going to talk about the application layer protocols. So on the application layer protocols, we have protocols such as the MQTT, COAP, HTTP, WebSocket, and so on. So in out of those protocols, we are mainly going to focus on IoT protocols that are used in IoT systems. So we will be talking mostly about MQTT and COAP protocols. So the reason is that these MQTT and the COAP protocols, they are very popular in IoT networks. So we will also go through a recap of the IPv4, IPv6 protocols. So these protocols are used to address devices and give a unique identifier for each device that is connected to the network. And then the IP, the Internet Protocol, defines the header such that it gives the information of the packet length, the time to leave. The time to leave parameter says like what is the maximum amount of hops that the data packet will get forwarded in the network until it gets discarded by the network. So the reason for having this parameter is because if we have a certain data packet which is traveling in the network too much of a time, then we need to discard such packets from the network to reduce the network congestion. So in order to have the such kind of packets roaming in the network, we are removing them, and based on the protocols that we use, based on the TCP and the UDP protocol we have retransmission mechanisms which allow the packet to be retransmitted from the destination, from the source to the destination. So therefore we define TTL and packet length, source address, destination address in the packet that we send. So these kind of standards allow us to send our data reliably from a source destination, from source node to a destination node. And at the each hop, these protocols decide the next best node to forward the packet using a routing table. So routing tables are used to forward packets at each node by checking the best node to forward it based on the destination node. So these protocols, these standards are followed in the network layer, and these are, I think you must have covered in the network layer based modules. So anyway, those are also important for the Internet of Things module, because Internet of Things module is related to this internet as well. So in the internet, we need to use these IPv4, IPv6 protocols to forward data packets from one destination, from one source to the destination. So using IPv6, a standard is defined called as 6LoWPAN. This I explained in the last class. So this protocol is such that it is proposed for constrained environments. So basically, we are using IPv6 addressing to address the devices in the constrained environment. So IPv6 addressing is used because we can dedicate a certain range of IPv6 addresses for the devices in the constrained environment. So rather than using IPv4, which is a limited addressing scheme, that means IPv4 can only address about 4 billion devices in the world. and therefore we constantly change the IPv4 address of devices from time to time in order to allow a certain IPv4 address to be used by another device. So because of that, the amount of IPv4 addresses are limited. So rather than using IPv4, IPv6 has been used to allow the addressing of the devices to be more static and to use a certain address for a certain device for a long time. So IPv6 addressing has been used to address the devices in this constrained environment. So these devices, they forward their messages across multiple hops to an edge router. So until the point where they reach the edge router, they are using the 6-low-pan protocol. 6-low-pan protocol is used. So in 6-low-pan protocol, apart from using IPv6 protocol, they are also reducing the header length of the IPv6 address in order to reduce the size of the packet length, which makes the packet a lightweight packet that will be forwarded in the constraint environment. So therefore, it is proposed for IoT and IoT constraint environments. So after the packet reaches the edge router, it will be forwarded to the cloud using the normal IPv4, IPv6 addressing. So the edge router here is performing as a gateway between the two different networks. So in here, in this constraint environment, we can use communication technologies like Zigbee, Wi-Fi, and these kind of 6-low-pan protocols can be used for smart meters, smartphone, home applications, right? So we have so we can use the edge router as a gateway in here. We don't need to use a specified gateway for this communication. So we can use several components for a gateway, but in here we can even use the edge router for the gateway purpose. So because the routers now are having the ability to identify the destination address and to which node it needs to forward the data to. So therefore it is a more intelligent component, and therefore it can behave as a gateway in this scenario. So as I said before, we have talked about the IP protocols, internet protocols, and then we talked about the transmission transport layer protocols, that are transmission control protocol and the user datagram protocol. So the transmission control protocol is a connection oriented protocol. That means that before sending the data to the destination, the TCP protocol first sends control messages and establishes the best route to send the data from the source to the destination, and then the data is sent in the data transmission time slot. So therefore, this TCP protocol is known as a very reliable communication protocol. So once you send data using TCP protocol, we are sure to get the data at the end destination. So if we don't have the data at the end destination, we can have retransmissions from the source. Anyway, we are establishing like a very reliable path to transport the data packet from the source to the destination. So in the user datagram protocol, on the other hand, we have some unreliability. So user datagram protocol is used for connectionless applications where it does not create a connection stable route from the source to the destination, but rather it sends or transmits its data packets to its neighbors, and the neighbors try to find what is the next best hop and forward the data to their neighbors, and likewise it gets forwarded based on the routing tables that each node has. And finally, some of the packets might get reached to the destination, but some packets gets lost when we are using the UDP protocol. However, this UDP protocol is also used in various scenarios where we need where we use like live streaming, for example, and at places where we need frequent update of some data. So in cases where we are watching a video or when we are having a live meeting, then we sometimes don't mind about losing some packets in between, because we are continuously receiving more and more data regarding that uh, online streaming from the source. So the source is also retransmitting the same data packet from time to time in order to improve the reliability of the data packet reaching the destination. So because of these techniques, UDP also manages to send the data to the destination. Uh, but some of the packets might get lost in between due to not having a reliable link with the destination. However, it is also used in some scenarios where we are giving frequent updates about the data to the destination. So if, for example, if you are measuring some kind of a parameter, let's say a temperature, then we give frequent updates. At every second we give some data to the destination, but losing one or two data packets will not matter, because we keep on receiving the data in real time from the source. So just losing some one or two data will not affect the average performance or average output of the uh, or reception or the data that is received. So we will be talking about the application layer protocols now. So MQTT protocol. So MQTT protocol is the first protocol that we are going to discuss under application layer protocols. So MQTT stands for Message Queuing Telemetry Transport Protocol. So uh, it was developed by Andy Stanford Clark in IBM and Alan Nipper of Eurotech in 1999. So this message queuing telemetry transport is a protocol, is a unique protocol for the IoT networks. So I mean, for IoT applications. So, I mean, when you are considering about IoT networks and other like network protocols, uh, in IoT protocols, we need to focus on mainly energy consumption and how easy, simple it is, right? So we need to have protocols that are lightweight and which are very simple to be used in IoT environments, and where we use sensors to collect data and very little amount of hardware to collect data and send data. So we don't have complex computations at the smart objects. So therefore, we need lightweight and less complex protocols to be used at the smart objects in order to get the data and send the data to the server, IoT server and the cloud. So therefore, this MQTT protocol is also one of the lightweight protocols. And in here, the special characteristic is that there's a component in which is known as the MQTT broker in this protocol. So we have uh, a component called MQTT broker. So it is like a server. It computes the data that it receives from a certain set of devices, and then it uses that data and sends that data to certain devices who have requested that data from the server, the MQTT broker. So we will learn about this in a little while. So it is using model called publish and subscribe model, and therefore we are doing some publishing and we are subscribing to some data, right? So it is very similar to the TV and radio broadcast, right? But there's some difference with this same from the IoT network, MQTT, and the TV and radio broadcast. So the difference is that in TV and radio broadcast, you all know that once we watch some TV channel, we are subscribing to that channel, right? So the radio station or the TV broadcast station, that station will only send that data to us. I mean, they will only select, I mean, they will select the channel that we have subscribed to and they will send that data to us. However, in the TV and the radio broadcast scenario, the people who have subscribed to the channel cannot publish data back to the radio station or the TV station. That we can't, start publishing some channel information to the radio station, right? So therefore, in that scenario, that is like only in one direction we have uh, the publish and subscribe uh, action happening. So uh, there's one publisher, there's one subscriber, right? Each role or each person cannot, or the radio station cannot be the subscriber, right? The user cannot be the publisher, right? So likewise, each person can only uh, be one thing. It can only be the publisher, and the other person can only be the subscriber, right? So in here, in the MQTT protocol, each device can either be a publisher or a subscriber. So they have both the functions enabled, and that is the difference between the MQTT protocol and the normal, publish and subscribe functions happening in the TV radio broadcasting stations. So I talked about something called the MQTT broker. So MQTT broker, as I said before, is a server that keeps a list of subscribers. So the server has a list of subscribers and it has like a table, right? It has a table and it has data about the subscribers who have subscribed to a certain topic, right? So I will explain using this example, right? So in MQTT protocol, there are two parameters. One thing is topics, the other thing is subscribers, right? So if some person has subscribed to some topic, the MQTT broker, it will keep that information in a table under the certain topic to which it has to which a certain device has subscribed to, right? So let's see this example. So in here, let's say like there are some sensors that we have placed around the earth, right, around different places in the earth, and we are taking measurements such as temperature, humidity, and so on, like weather conditions and so on, right? And we are collecting those sensors and we are publishing those sensor data to this MQTT server, right? So the sensors are sending data to the MQTT server, and they are using the publish function to send the data to the MQTT broker. And then there are subscribers who are subscribing to that data. So there's one subscriber who wants the vibration information, right? So MQTT broker, it will have a topic called vibration, and under that vibration, it keeps the ID of the device which has subscribed to that data. So once the broker receives some vibration information from this earth, from these sensors in the earth, it will send that data to the earthquake monitor, right? So likewise, if there's another person in London, for example, who wants to know the temperature, sorry, there's a subscriber who wants to know the temperature in the location London. So it has subscribed to the temperature in London. So once the MQTT broker receives temperature data from the different locations in the earth, it selects only the data relevant to the London temperature, and it selects that data, and then it will send that data to the subscriber, right? So the MQTT broker is responsible for sending the necessary data to the subscriber, right? So MQTT broker is collecting data and sending data to the necessary devices, right? So if you have any questions, please let me know in the chat. So I hope you understood the basic concept of MQTT, right? So MQTT protocol can be implemented in IoT networks, and the role of MQTT broker is very important in MQTT protocols. I say MQTT broker, as I said before, is a server. Right? It can be two types. There could be two types of brokers. One thing is managed broker, and the second type is self-hosted broker. So the managed broker is a type of is the broker which is uh, controlled by a third party. There are several companies which are providing that the MQTT broker and the infrastructure related to that via a certain platform, right? That platform is already built. We just need to use it, right? So companies like AWS, Azure, Mosquito, Hive MQ are some companies which are providing that service to us. And so if we are using that sometimes we need to follow their guidelines and standards in using that. So we only can use some functions that they have defined, and we need to get our work done. However, these brokers are very secure in terms of functioning. They are very secure. They are securing the data, and also they are managing large quantities of data such that it is easy for us to let these companies or the brokers or the softwares that they have provided. It is easy for us to use those softwares rather than using our own servers to do that. So in cases where we have large amounts of data, it is ideal to use these third-party infrastructures to store our data and use them because sometimes we don't have the resources to store large amounts of data and manage them flexibly and securely. So the second type of broker is MQTT broker, is self-hosted broker, which means that we have a broker which we can host in our own computers, right? We can set up the MQTT broker in our own computer, in our own laptop, and then we can set up connections with the devices, right? With our IoT devices, we can set up connection, and then we can use that. Also is provided, the software is provided by these companies Mosquito and Hive MQ, and the software is open source, so anybody can access that software, download and install it, and they can also refer the sample codes and implement the procedure to set up the MQTT broker and implement its functions, right? So these are the main MQTT broker types that are available, and there are advantages and disadvantages on both the types. So this is another scenario of MQTT protocol implementation. So in here, what happens is that there's MQTT broker, right? And there's a sensor that is publishing temperature information frequently within fixed time interval, for example, to the MQTT broker. So once the MQTT broker gets the information, it checks like who are the client devices which have subscribed to the temperature topic, right? So after identifying that, the MQTT broker will publish the temperature data to the clients who have subscribed to the temperature data. And so these clients have already, subscribed to the topic temperature beforehand, right? So once we want to implement our own MQTT, we need to configure our devices to work under the MQTT protocol. So we need to, when we take, for example, this example, when we have a situation where we have a device that is measuring something, let's say measuring some data temperature, for example, and it is sending that data in continuous time intervals, fixed time intervals to an MQTT broker, right? So once the MQTT broker gets the data that is subscribed by a certain other device, right? So there's another device which is subscribing to that data. So that data, the broker will publish the necessary data to the ESP2 device, right? So in this scenario, we have to code in this microcontroller board in a separate manner, such that this ESP1 device will behave as a publishing device, and it will publish the necessary data to the broker. And then ESP2 device, it will receive the data under a certain topic. And ESP2 also can publish some data to under a certain topic. So likewise, we can build this ESP1 and ESP2 devices to connect to a MQTT server, right? So to do that, we need to define certain parameters, such as what are the topics to which this microcontroller board is publishing to, and what are the topics to which it is subscribing to, right? So there are two functions, publish and subscribe. We need to define these functions properly in this ESP1 and ESP2, such that these devices will get the information that they have subscribed to, and it will publish the information that they are intended to publish. So we will see how this ESP1 and ESP2 can be coded, right? How the code in these two devices can be implemented, right? Okay, so one student has asked, like, how the end devices receive data. So do the end devices receive data on the request, or it continuously follows to the subscribed clients? So uh, first, before the implementation of the before collecting the data at the temperature sensor, let's say, right? Before collecting data at the temperature sensor, the devices must be configured as the end devices must have turned on their subscribing topic, right? So what I'm saying is that ESP2 must decide that device is subscribing to the topic temperature before it before the temperature is getting collected in here, right? After subscribing only, it will receive the temperature data. If it does not subscribe, the data will not go to the ESP2, right? So the ESP1 device can collect data, right? Can collect temperature data anytime, right? So until this ESP2 gives the connects to the MQTT broker and notifies the MQTT broker that it is subscribing to a certain topic, the broker will not know, like, that device needs the temperature data. So therefore, in this MQTT protocol, data does not continuously flow to the subscribed. Continuously flow. First, the subscribed device, the device must subscribe to a topic, and only on that request only the broker will send the data. So right? The devices have to first subscribe, right? After that only they will start receiving data from the broker, right? I hope that is clear to you, right? So if you have more questions, please let me know, right? So let's go to the code, right? So this code that I'm explaining here is available in this website as well. So I will show you that website, right? So this website shows us how we can implement the MQTT protocol on a ESP32 board or ESP8266 board. So we can have uh, this implementation, and we need to follow these steps to uh, implement the code in the ESP32, and then we need to follow certain steps, and we need to implement the code in each device in the network, right? So we are considering a situation where we only have two devices, right? So we are having one ESP1 device and another ESP2 device, right? So ESP1 is publishing to a certain topic, and ESP2 is subscribing to that topic, right? In here, in this example, they have taken two topics, right? Hello and notification, right? So these two topics have been considered in this code, right? So we can see like how the notification topic has been allocated and Halo topic has been allocated as subscribing and publishing topics. So at first they are coding uh, the ESP1 device. So under ESP1 device, the topic to which it is subscribing is the notification topic, and the topic to which it is publishing is the hello topic, right? So this is under this scenario, the ESP1 is publishing to this hello topic, and it is subscribing to the notification topic. So likewise, the code has been built like that, right? So this type of a code we can use for our own work. So we need to just adjust the topics, right? Adjust the topics and other variables that are varying with our network to adjust this code to our application. I don't need to write the code means what do you mean? Don't read. So we need to actually implement the code in the ESP32 microcontroller. So we have this kind of a IDE, right? Once we have this ESP module, we need to install a platform in our computer, right? We have something called IDE, that means UPyCraft IDE, which is compatible with Windows and Linux and Mac OS. So in there, we can install this. So it is like a coding platform. We can write the codes in this platform. So we need to have UPyCraft IDE in this instance because we are using the Python, like micro Python language to code this device. So we need to go through these steps. We need to install this setup, and then we need to write the code inside this platform. Once we write the code inside this platform, and we can open a file called boot.py, and we can write this code there. So once we have done it, we can burn the code into the ESP32 controller board. So that burning function also is there built in this IDE. So once you have written the code, you have to write the code, then you have to burn the code to the microcontroller, right? So we are now going to consider a scenario where we are going to adjust this situation to a situation that we want, right? We want to publish under a topic called temperature, let's say, and we want to receive notifications that the subscribing device has received that data, right? So how are we going to change that? So let's look at that, right? So I will explain, like, in this presentation I have um, this code, right? So that same code I'm explaining in these slides. So one thing to notice that we can write in both C++ and MicroPython languages. We can have any of these languages when we are doing ESP32. When we are using ESP32, in there we can use any of these two languages. So if we are using C++, we need to import the necessary library. We need to use the library called pub/sub client, and we can take the functions that are related to this MQTT protocol using this pub/sub client library, right? If you are using MicroPython, you can use this library, right? You can import this MQTT simple library and import the MQTT client module, and from that you can obtain the functions that are specific for the MQTT and use that in your code to easily uh, do the functions of publishing and subscribing. And this MicroPython is like a simplified version of Python, which is useful when we are burning codes in our microcontrollers. So since Python is a very powerful and powerful language which needs more powerful processors and computers to work with, MicroPython is used in this scenario which does not need high resources, high amount of resources. So MicroPython is used for situations where we need to run uh, under low power controllers such as ESP32, Raspberry Pi, and Arduino boards, and so on. So we prefer like MicroPython over Python in these scenarios. So this is like on the right hand side, we have this code which is written in C++. However, I think we are going to look into implementation in MicroPython in this example. So I think MicroPython is much more easier than C++ when we are working. So it is easier to understand, and I think it's very similar to Python, which is easy, easy programming language. And first, when we are going to implement our system, we are now going to publish temperature data to the MQTT broker, right? And we are going to publish that data under fixed time intervals, right? So we need to define those parameters in this code, right? So the first thing in this code that they have done is importing the required libraries. So required libraries can be imported, right? There are several libraries that need to be imported, not only related to MQTT, but also about which are required by ESP32 for it to function, and then the Wi-Fi modules and so on. Once you have imported the necessary libraries, we can then define, like, what are the Wi-Fi to which these devices getting connected to, the Wi-Fi name, Wi-Fi password we need to give. And then the MQTT server, right? The MQTT server is the, under this parameter, you need to define the IP address of the MQTT server, right? So if we are using a local server, we need to give the IP address of the local server or the local computer that we are using as the MQTT broker, right? So it can be some value like 192.168.1.144 likewise, right? So we can get the IP address of the MQTT server as the parameter here, and we can enter that. So it depends on the MQTT server IP address. And then we have to define the client ID, which is the unique ID that they define for the each device that we are considering, each ESP device. For the ESP device, we can define a unique client ID by using this function. So the machine.unique ID will give a unique ID for that ESP32 device, and then that will be taken as the client ID. And then we have the topic up to which we are publishing, right? The topic to which we are publishing should be temperature, right? We are publishing our data up to the temperature topic, right? So, and then we are subscribing to another topic, which is called notification. So notification is another topic where we receive data that is published under notification, and we are receiving some data, right? Some notification data, some kind of a message. We are receiving some kind of message, right? So we have to define these two parameters correctly in order for us to get the correct subscribing data and publish our data to a correct topic. Then we have the initiation step, right? So initiation step means we are initializing some variables. So we are defining that these parameters, there are certain parameters defined here. So the last message in here, the parameter last message means like the time at which the last message was sent to the MQTT broker as the publisher, right? And then a message interval means like within what fixed intervals we are sending the message to the MQTT broker, right? So we are sending during each fixed 5-second intervals, we are sending data to the MQTT broker. So that frequency we are defining as message interval here, right? And then counter means how many messages we have sent, and we are counting the total number of messages we have sent, right? So the last message here means the time at which the message was sent. So we can check those variables in the code that is available, right? And then we can also connect our network to this Wi-Fi using this code, right? So in this code, we are defining different parameters. So these parameters enable us our ESP to connect to the network. So in here we only need to define the SSID and the password. Other things are already defined in the libraries and modules. So the rest of the things need not to be changed. So we can also this loop, which the while loop is about connecting our device to the Wi-Fi. Until it is getting connected, this while loop will run, right? So it says that if the station is connected is false, that means if the ESP is not connected. If it is false, then the while loop will run, right? So while loop will run until the connection is made. So this allows us to connect to the Wi-Fi, and until the Wi-Fi is connected, this loop will run. So yeah, for the code, no, for the exam, I will not ask memorization of these codes. But I think you need these codes for the project you're doing. So that is why I'm trying to explain. So you can just implement this code in your project. In your exams, actually, I will mostly, if I'm asking a code, I will ask a code, not the full code, but I will ask at which positions you need to change the data and so on, right? I will ask you to just fill in the blanks with some parameter data or some data that I have provided in the question, right? So you need to just know how to plug in some data into the code and use that existing code for some application, right? I will give the code. I will ask you to do some changes in the given code, right? And then we have some functions that we need to define in our code. Yeah, we define a function called sub, right? The callback function, we call this. This function we call as sub underscore CB, right? So So have you learned Python in your previous modules? Right. So if you have learned Python, if you have done Python, I think you can understand these kind of codes, and you can understand like what type of a function is this, and what type of a activity that is done here. Oh, right. It will be easy if you have like learned Python earlier. So have you learned Python earlier in one of the modules you have covered or not? Okay. So uh, anyway, so in here we need to we are defining a function called callback function. So this callback function is uh, used to notify us of an event, right? It responds to a certain event, to a certain like specific event. So once our once our system receives our ESP device, right? One of the ESP device, once it receives some data, this function will get activated, and it will store the information that it receives, right, under certain topic, and the message under that topic will be saved, right? So that is the function that is done in this uh, code. So it will get the topic information and message information, and it will show that it has received those topic and message information. That is what is done in this code, where we are printing the messages that we have received, right? Anyway, the callback function is just to collect the data we have received. uh, Once we suddenly receive some data from the MQTT broker, in this case, right? We suddenly receive some data under a certain topic and message. So that sudden reception of data we collect under using this function. And then we have the next function, which we define as connect and subscribe. So the connect and subscribe function we are using to connect our devices to the MQTT broker, right? And then also we are going to subscribe to certain topics, and we are setting up the client device using this function. So in this function, we are setting up what is the MQTT server and what is the client, and then we are making the connection between the MQTT server and the client. And then we are also defining what is the topic to which the client has subscribed using the client.subscribe function, right? So likewise, we can run this code to connect our client device to the MQTT broker. Okay. Okay, so I hope, yeah. Okay, so we can continue. So the uh, temperature will be formed as a message, and we will publish that message under the certain topic, and the message will be sent. And the last time the message sent was is recorded as the that current time, and it will be counted using this counter variable, right? So that is how this code works, right? So and then we have some other functions in here. We define restart and reconnect. That means we are going to restart our network, and we are going to reset our machine to to maintain the connection with the MQTT broker. So if our machine stops sending data, for example, and it loses its connection, this code is run to reconnect with the MQTT broker, right? So So that is what is done under restart and reconnect code and function. And then normally we are running these codes like call try, and then we are following this command. And then uh, if this does not work, then we need to restart our machine, and then we need to reconnect back with the MQTT broker. So those are the basic things that I wanted to tell about that code. So as I said before, you can refer the website that I showed you before that explain this concept to build the code that you want for your application, right? And then you can implement that code, right? So we talked now about only about ESP1 device, right? We only talked about ESP1 device. ESP2 device also can be configured based on the same concept. The only thing is we need to have a different topic to which we need to define the topic and the publishing topic and subscribing topic correctly for the ESP2 device, right? So we will discuss about that as well, right? So so under this under the ESP2 device, right? What as you know, like what is the topic to which it should subscribe, right? So I said that uh, we are considering a scenario where we are subscribing to the topics, subscribing and publishing to the topics temperature and notification, right? When we are considering the device 2, what is the topic to which it is subscribing to? Is it subscribing to the notification topic or to the temperature topic? It is subscribing to the temperature topic, right? So in ESP2, once we are setting this parameter, we need to define the topic subscribe as temperature, right? And the word B here is meaning that we are giving the value of the temperature as a binary format, right? We are sending a string, but we are turning into binary, and we are storing that as binary under this variable. So, and then the topic to which we are publishing is a notification, right? We are publishing our data to notification topic uh, uh, under certain after a certain situation occurs, right? So we are considering a scenario where we are receiving temperature data at the device number 2, and once we have received the data at the device number 2, we are publishing a notification to the under the notification topic that we have received the temperature data, right? So under the notification topic, we are sending some data to the MQTT broker. We are sending that data as a string, as some kind of string. So we will talk about that as well. So under other parameters, we need to define the Wi-Fi SSID, the name of the Wi-Fi, the password of the Wi-Fi, MQTT server IP address, the client ID. So these parameters we need to define for the device 2 as well. So when we are defining, it could be the same Wi-Fi network that we are using as the device 1, or it could be a different Wi-Fi network from the device 1. Right? So we could be remotely monitoring the temperature data at a certain location. It might not be the same location. So the Wi-Fi connection might not be the same Wi-Fi. But the MQTT server that we are using is same for both the devices. Right? So device 1 and device 2 both connect to the same MQTT server. So the same IP address must be there. The client ID, right? It should be a unique ID for the device number 2. The device number 2 will generate its own unique ID using that command that I mentioned, unique ID command, right? So the same function will be applied in the device number 2 also to connect to the Wi-Fi, right? So after connecting to Wi-Fi, we are using this code to connect to the Wi-Fi. So this is uh, the uh, the answer to the previous slide. So we have to subscribe to the topic temperature and publish the topic notification in our scenario. So the callback function also same as the device one, so nothing changed there. And then in connect and subscribe function, we need to define the correct subscribing topic. And that is all basically. I mean, once you have set up all these parameters in the initialization stage, those same parameters will be applied in these positions in the code, and you don't need to do changes in this code sections, right? So the important function that is happening here is in this section, where the device number 2 will check whether it received a new message, right? So it is receiving a new message under the topic temperature, right? Under the topic temperature, it is keeping on receiving temperature data, right? So once it receives a new message, right, it will be saved as a new message once we call this function client check message. Once we use this check message function, whatever the message that is stored there will be saved in the new message, right? So the check message function is related to the callback function. Callback function we defined earlier, which saved the message under a certain topic. So the check message function is used after the callback function. I mean, it can be used after the callback function because the message that is stored by the callback function will be checked by this check message function. So the new message that is saved there will be taken, and if it is not an empty one, that means if there's some message properly received, right? None here means like whether it's empty or not. If the new message is not empty, then we know that we have received some data. In this scenario, since we are only receiving temperature data, we know that whatever the message that we have received is only temperature data. And then therefore we are publishing to the topic that we are publishing to, which is the notification topic, that we have received the necessary data, right? So we are sending this message under the topic notification, and then we are sleeping for 1 second. So if that does not happen, if this function does not happen, the machine will restart and try to reconnect to the MQTT broker, right? So in this first part of the code, what we are trying to do is we are trying to publish the notification message under the notification topic, right? So we are sending a message saying we have received the temperature data. So that is what is happening, what is possible in this code, right? So I have talked about basically MQTT and how we can implement it in the ESP32 device, right? So so do you have questions regarding the code and how we can implement it in the code and so on? So I will also I need to explain to you about the assignment that I have given you under this MQTT protocol, right? So I will explain that also in a little while, right? So if you have questions about this MQTT protocol and how it functions, you can let me know, right? So I would like you to go to this website and get more information regarding how it works out, uh, and like how the code is functioning, so that you can get more information about this scenario and how it works in the real world, right? How we can really implement that using these kind of devices and a server, right? So once we have this MQTT broker, right, we have to implement that also, right? The MQTT broker we can implement in a local computer, right? In our laptops we can install the device server software, and we can start connecting our server to devices, right? So we need to set up this MQTT server using some software like Mosquito. There are some software companies that provide that tool. So Mosquito is one, and there's another one called Hive MQ. So those are free tools, that free software tools that they are providing. So we can use that to implement an MQTT broker in our laptop. And then we can connect to that to the devices that we want using by following the initialization stage, and like specifying the ports and whatever the other parameters. And then we can set up the connection with the devices. So once the device is publishing some data, the data will be shown in the broker. So the broker will keep on getting data continuously, and then it will also send the data to the necessary devices to which the I mean the MQTT broker sends the data, right, to the client devices. So we need to implement all these components in order to do this communication, right? So we can implement all these protocols and in these devices, and we can set up the connection, right? So we have all the steps in this website, so you can refer that, and you can get more information regarding the implementation. So the explanation of the codes are also there. And so I would like to also mention about the project or the assignment that I would like to give under this MQTT protocol. So right, so the details of that project is already uploaded in the LMS, and you can get the details uh, uh, under this page in the LMS. Right, in the PDF we have all the instruction there. And then in the Google sheet that I have provided, you need to mention like with whom you are doing the project and so on, right? So all those details you can mention in this Google sheet, and then you can have the instructions in the PDF file, right? So apart from that, right, so last time I think some of the students asked me about industrial IoT, right? Industrial IoT and how the industrial IoT is working. So in industry, we know that we have like high-end sensors, right? So we have like the sensors which are big and which are more able to withstand rough environments, high temperatures and high pressures, and so on, right? So industrial environment requires like very solid objects to sense the data and process the data. So in that case, we have different sensors specifically for that environment. So we have sensors like air quality monitoring sensors and the flow monitoring sensors, right? So these sensors are defined for the industrial situations, right? And the temperature sensors are also very much like rigid and very much suited for like high end difficult extreme environments, right? So we have big large scale sensors for industrial environments. So we have in our industrial setups we have production lines, right? In those cases we need to install these kind of sensors at each place, and then we can connect that to like PLCs and so on. So in industrial environments, we are using these PLCs, and we are collecting information about each sensor, and we are storing data in certain databases, right? So now actually instead of PLCs, right, industries are introducing these kind of Arduino based boards to be used instead of the PLC. Right, so instead of the PLC, we can use these kind of Arduino boards which work with high voltage inputs such as 24 volts, for example. So these can just be directly used instead of PLC in the industry, right? The advantage here is that we can flexibly monitor, or we can flexibly change the functioning of this processor, right? Whatever the process that is doing using the data that we collect, we can change easily using these boards, right? Rather than using PLCs, right? So in PLCs, we have different programming mechanism, right? We have ladder based, like programming languages that we need to follow in order to get our output, right? However, in the nowadays we can use Arduino boards as well. So the advantage of using Arduino type of boards is mainly because there are so many sample codes, sample applications have already been implemented, and people are uploading how to do it in the website and so on. So much help is there when we want to implement something. So we can quickly connect these boards to our computer, we can burn the code in there, and we can use it in any, in industry, and we can plug in the power and all those inputs into these pins, and we can get the data that we require, and we can do the computations, right? We can apply some other things as well, right? We can install LED monitors, we can monitor the sensor data from this board itself. Also, this board is not that thick, right? In the PLC, that it is a kind of a large, something like this. It needs more space. But the Arduino controller board, which is kind of thin and lighter than PLC, can be used instead of PLC. So there are industrial Arduino boards which are used instead of PLCs these days. And then we have also some type where we have integrated the PLC with the Arduino board capabilities. So based on Arduino processor, we are building this PLC, and we are allowing a lot of input output pins, which allow a lot of sensor data to be collected and to be output from this device. And then we have different USB connections and ports enabled, which allow the communication between this device and other components. We also have another, kind of a processor, right? That is similar to the PLC, which is able to do the functions that a Raspberry Pi controller board can do, right? I mentioned that Raspberry Pi is a very high-end controlling board which can do some processing, like image processing and complex computations, which are used for computer vision, for example, applications, right? So we can take images, we can classify them, we can do machine learning. So likewise, we can do computations as the Raspberry Pi. So that kind of ability is incorporated into these kind of devices, which can be used in industry. So we are able to use these kind of devices, which are almost like computers at the end of the, at the edge of the device, and we can get sensor data, and we can do computations at the industry. So in the industrial environment, we can use these kind of boards, right? So these are the sensors, as I mentioned, that we can use. We can connect that to the PLC, right? We can connect the sensor data to the PLC, or else we can directly connect that to a board which connects to the cloud, right? So such components are also available. So we can directly connect our temperature sensor data to a box, in this company it is known as the cloud rail box, and it is sending whatever the collected data directly to the internet using the Ethernet connection, and the cloud database is collecting the data continuously from the temperature sensor, right? So we can have such kind of implementations in the industrial scenarios. So rather than using PLCs, now we can actually use microcontroller boards to amplify the computation at the industrial sensors, and whatever the computations we require at the sensor level. and we can increase the efficiency of the system, and also we can reduce the space that we require for the processing by using high-end controller boards like this, where we don't need much of a space that we used to need in the earlier case, right? So actually now the PLC is connected to the sensors, right? So PLC is connecting the data, right? So it is like if it is, I mean, so if it is the sensor at the sensor, I mean, if it is collecting data near the sensor, we can collect we can consider that as the smart, I mean the object that is collecting the data, but it needs to send that data to the internet. So in order to have that internet connection, you need to have another device that connect this PLC to the internet, right? So we need to connect another module that connects the connects the PLC to the internet. So only then that PLC will be considered as IoT device, right? The total, the sensor plus PLC plus the connection module will be considered as the IoT device. So Raspberry Pi and Node MCU, they are used in IoT because actually, I mean, those boards have the ability to connect with the internet using the communication modules they have, right? So rather than doing some computation at a certain location, right? If they can communicate that to a remote location, then it is useful in IoT communications, right? So since they are inbuilt with Wi-Fi, Bluetooth modules, we can transmit the data to a remote location. So therefore we can use in IoT situations, right? If they don't have the communication ability, then we can't use it in IoT, right? But if they can send it to a local server, right, to another device which can collect their information, right, and send it to the internet, right, who has the connection with the cloud, then we can connect our Raspberry Pi to the IoT network. Right? Raspberry Pi is there in IoT networks because it can sense the environment and make decisions. Right? For example, Raspberry Pi can be used in situations where we need to take images. Right? If we take images from some kind of a camera or something, we can process that data at the Raspberry Pi itself, make some decisions, and then take that decision to the IoT network, to the cloud network. So we might need this. I mean, if you're asking why we are need this computation, why we are not sending the data directly to the cloud, the answer is that we don't have the resources, or we want to do our activity with minimum cost. So the first possible thing is that if we identify some problem, right? If at the industry, let's say, if we are collecting images about the machines in the industry, and if a machine is not functioning, then Raspberry Pi will identify using the images it collects, and it will give only that data to the cloud, right? It will send only that data to the cloud. Okay, this now there's some malfunctioning here, so do something about that. That message only will be sent, rather than sending all the images to the network. It is very like cost efficient if we only send the important message to the network, right? I hope you will agree with me. So the network traffic will increase if we continuously send high amount of data in the communication link to the local server, right? So the network traffic will increase, and therefore the connection will get slow. in the environment. So therefore we need to produce less network traffic, and we need to do our communication efficiently using the wireless medium. So therefore we only send the important data at certain applications, right? That is why we do the computation at the sensor level. We send only the data that is necessary. Sometimes we might need to send the data frequently to the sensor, to the server, right? In situations where we require that. But in some situations where we don't require that, we only send the important data. That processing will be done at the Raspberry Pi or other microcontroller board. Right. So I think I explained to you about those questions, and the mark allocation breakdown for this module will be as like this, right? So I have decided to give 20% for the assignments, right? For the assignments that I will give in the LMS will constitute will contribute to 20% of the mark, and the group project that I'm giving will take 10% of the mark, right? Then the mid exam will 20% and end exam to 50%. So many students actually ask about this mark allocation and the breakdown. So you can do like, we can do like that, right? And then we have the for the mid exam, we are I'm hoping to give a writing exam, and end exam also writing exam. So that you will, I mean, you will be answering questions related to the theories that are doing in here, right? So the group project, when I say project in here, I need to explain to you that it's not a novel project that I'm explaining or I'm expecting from you, right? I'm giving you steps to follow, and exactly that steps you need to follow. Then you need to just implement the scenario that I'm asking you, because this is IoT module and I am only asking you to do the IoT protocols or something related to IoT to be implemented. So you don't need to do something that novel or something like that. So you don't have to put a lot of effort. These are like very small activities that I'm giving, right? So one group project I'm going to give, only one, right? So, and then we have the assignments, right? So I will explain to you the project that I'm giving, right? So if you have questions, you can let me know. So a lot of students asked about this project. So if you have questions, you can let me know. So I will stop actually the content of today's lecture. So from the next lecture onwards, I will continue doing the details regarding the protocols, right?